Good morning, everyone. I am Chethan, and these are the team members of ADF. These two Alsamad and others and Abhishek M. Patel. And today we have to discuss about an assignment, ADF assignment, BJT, its functions and OPAMP of principles today. And these are the contents: introduction, BJT switch circuit, and explaining about inverting operational amplifiers, and also non-inverting operational amplifiers and methodology. Introduction. I will explain introduction. Bipolar junction. Bipolar junction transistor. It is a it is a It is a three-dimensional semiconductor, three-terminal semiconductor device used for amplification and switching. It is made by three layers of doped semiconductors materials formed either NPN or PNP, PNP type structures. The three terminals of BJT are emitter, base, and collector. In a BJT current flow, the collector and emitter is controlled by a much smaller current at the base. Which makes useful as amplifier because both electrons and holes participate in conducting called bipolar devices. BJTs are usually electronic circuits such as audio amplifiers, signal processing circuits, switching circuits, oscillators. I am also introduction about operational amplifiers like an op-amp is an high gain differential amplifier used for amplify voltage and used to amplify voltage signals. It have two inputs terminal and one output terminal. The one output terminal and input terminal. The two input terminals are inverting terminal, and there are two types of input terminals: inverting terminals and non-inverting terminals. An op-amp is a differential between voltage between these two terminals. Ideally, it has a very high input impedance and a very low output impedance, which makes it suitable for many applications. Op-amp are used in various applications such as voltage amplification, signal filtration, comparators, integration and differentiation, oscillators, signal conducting. And next, BJT circuit will be explained my friend Others.
Hello everyone, myself Adarsh TS. I am explaining about the how BJT acts as a switch. BJT, it means bipolar junction transistor, is an electronic device that can control current. It has three terminals: base, collector, and emitter. The BJT works like a water tap. It means if small current flows into the base, a large current flows from collector to emitter. If no current flows into the base, the transistor stops the current. That's why BJT can work as a switch. In BJT, two states. One is off state, it means cutoff region, and another one is on state, it means saturation region. In off state, base current is zero and no electrons are supplied, and the transistor is off. No current flows from collector to emitter, and it becomes like an open switch. For example, you do not press the button, the light does not glow. And another one is saturation region. In saturation region, sufficient base current is given and transistor turns fully on and maximum current flows from collector to emitter. The BJT behave like a closed switch. For example, the current flows, light glows brightly. And BJT used as a switch because it turns on or off very fast and it needs only a small signal at the base. And it control large current using a small current. Widely in LED controls, relay driving, microcontroller circuits, motor control. And rest will be explained by our friend Abhishek.
Hello everyone, myself Abhishek. Today I would like to talk about concept of inverting amplifier. which is one of the most fundamental circuit in analog electronics. It is widely used in signal processing, instructions systems, control system, and audio electronics. Now, an inverting amplifier is an operational amplifier configuration where the input signal is applied to the inverting terminal and the non-inverting terminal is usually grounded. It means the term inverting means output signal is 180 degree out and phase with the input signal. In simple words, we can say that when the input goes positive, the output goes negative, in vice versa. The circuit is extremely popular because it provides excellent stability with predictable voltage gain, high input resistance, and very good necessary accuracy, especially when using ideal. Next, to understand inverting amplifier, imagine that operational amplifier has two important rules. The input terminals draw almost zero circuit because op-amp has input impedance in very high. The op-amp will try to keep the voltage difference between two inputs equal to zero as long as operating in linear region. Next, inverting amplifier non-inverting terminal is positive is connected to ground. Op-amp tries to keep inverting terminal negative same voltage, which means it stays. It also known as virginal ground. Next, because of this condition, the current entering through input resistor pass through feedback resistor and the relationship creates the voltage gain. And next topic is explained by Alsamat.
Hello everyone, my name is Al Samad and now I am explaining non-inverting amplifier. Non-inverting amplifier is an operational amplifier circuit configuration that amplifies an input voltage signal without inverting its phase. Input applied to non-inverting terminal. The input voltage is applied directly to the op-amp non-inverting into input terminal. Positive positive gain. The voltage gain is always positive and greater than or equal to its unity. High input impedance. The circuit offers very high input impedance which minimize the loading effect on the signal sources. Low output impedance. The circuit has very low output impedance. Now negative feedback is used to control the gain and improve stability. The gain of an ideal non-inverting amplifier is determined by two external resistance, RF and R1. Non-inverting amplifier are widely used to various electronic circuits. Impedance matching useful for one and R2 controls the gain. The op-amp adjusts the output so that the voltage difference between plus positive and negative terminals become almost zero. Output becomes an amplified version of the input. Signal application. The non-inverting applications are sensor signal amplification, impedance matching, and audio amplifiers, data systems. The input signal is applied to the positive terminal. It means non-inverting. The output signal in phase with input is 180 degree. High input impedance is very small input current and low output impedance is good for driving loads. Next topic will be explained by my friend Chethan.
Hello friends, I am continuing methodology. We use a BJT either as off state switch or on state switch, closed switch for controlling loads like LEDs, motors and relays. Use a NPN transistor in a common emitter configuration. Emitter connected to ground, load connected method between supply voltage and connector, base connected to the input control signal through a resistor, off state cutoff region when no base current flow. Base emitter junction is not forward bias. Transistor is off. No collection current. No collector when transistor is off. No collector. No carry a current flow. Current flows does not current flows in a collector. BJT behaves as a open switch. Okay. On state andre saturation region when a sufficient base current is applied to the BJT base emitter junction become a forward bias. It become a forward bias like silicon 0.7 volt. The transistor either saturation region collector current become maximum. That region current become maximum. Collector current become maximum when BJT behaves like a closed switch. These are the methodology about BJTs. And today we'll explain this topic will completed and
Thank you.
thank you to all.